Hans talked about NA. We have an AMSAT Canada now, so we can't use AMSAT NA in North America anymore. But in any case, AMSAT in the US, I volunteer as the lead software developer for Golf and FoxPlus-A. And so thanks for inviting me to present at the AMSAT South Africa Symposium. It is always great to see you, even remotely. I haven't always been remote. 2 years ago, it was great to meet AMSAT SA and SARL members. I was lucky enough to be in South Africa for a singing group and took a day off to visit. So thanks for all of you who took some time to see me then. So in general, what I want to talk about is the current status of several projects that we're working on, Golf T, FoxPlus-A, and FoxPlus-B, which is also known as a more specific version of PACSAT. Now, you've probably been hearing about, I've been talking about Golf T for, good heavens, 7 years, I think now. But I think we're finally making some progress on it, so I'll try to share a little bit of stuff that's going on there. But the first project to talk about is Golf T. It's, as I may have said before, it's largely a program to develop technologies for higher orbits. Golf stands for greater orbits, larger footprint, but Golf T itself will be in a low Earth orbit, but it's there to test things before we actually can go into a high orbit. So currently the regulatory environment here in the US makes it really difficult to get small non-commercial organizations like us to have high orbit satellites. But one group of volunteers is working on that. And in the meantime, Golf T is moving ahead to launch into LEO. So some of the technologies we want to test are the 10 gigahertz, here we go, got a pointer, 10 gigahertz downlink and several microwave uplinks. It'll be fully attitude stabilized thanks to CubeSpace, a company in the south of South Africa, which I visited a couple of years ago as well. It'll have deployable solar panels for that reason. That'll give us more power, a directed microwave antenna, all of which we can do because it's attitude stabilized. We have a redundant IHU, an onboard computer, with command receivers, telemetry transmitters, and so on, and also kind of the standard 30 kilohertz VU linear transponder. But I said we've been talking about this for years, but we've also, because of that, had a lot. I mean, the reason for that is we've had just an enormous number of delays and bad luck. One key team member and friend became a silent key. That's Bob Davis, KF4 KSS, if any of you knew him. There's the supply chain problem. The original ADCS, attitude control system supplier and power system supplier, could not deliver. So we had to restart. Experienced volunteers, and I'll volunteer to be one of them, are getting older. Yep, I guess we all are. And unfortunately sicker. So there's lots of delays there. But we do have a lot of new volunteers, like this guy. So the program is going ahead with some new volunteers. Just to kind of remind you, if you haven't seen this before, the way Golf T looks like is, and I just got a notification that I'm having network issues, so I hope that you can hear me okay. And I can turn off my my camera if we need to reduce the bandwidth any. But this is a picture of this 3U CubeSat that is Golf T. The kind of standard 1U part that we've flown before is right here. And then we have an Edis E310, which does the microwave work. The ADCS is down here. The power supply is here. And a GPS system and a connecting board that connects everything is in here. And you can see this picture is several years old. The general orientation has stayed pretty much the same, but there have been a lot of details to work out, including the locations of Earth and sun sensors for the attitude control system. But the main reason I want to show it is to give you the idea that Golf T is pretty complex. Our Fox satellites look like this. You can see the red line here. This is pretty much what was in our Fox satellites, plus some batteries and MPPT, for the solar panels down here. So all this other stuff is new and complex. So as of a year or two ago, we had a 3D printed model of the Golf T satellite. This I may have shown you before, and it's been on display in a few places. But again, you get the idea that this is what we call the transverse stack, the original boards that are pretty much done. Here's the GPS, the microwave radio, ADCS, and so on. But now we are making this is sort of our first CAD models that we use to develop this stuff. But now we are at the point of having much more explicit CAD models and some really great mechanical engineers that are able to actually make metal models. This is displayed in May at the Hamvention in Dayton, Ohio. It's even to the point where we didn't want people touching it, so we had it in a glass case like this. But this is an all-metal model with some real boards inside it. So, and you can see the transverse stack is right here. And the other stuff that were bright colors in the 3D model are now more dull, but this is closer to real. And one of the solar panel, folded up solar panels is on the edge. So we are making progress there. Here's what it will look like in space. Again, using a 3D CAD model. The solar panels all open up. You can see on each of the Y sides here, the solar panels open up twice. So each side has twice as many solar panels as it would folded up. Plus, they're all pointed in the same direction. This side is fixed, and there are also solar panels on the minus. Let's see, this is the minus Y side that I'm pointing to, just in case when we get slightly misaligned from the sun. This is down here a deployed 10 gigahertz patch. This is the 10 gigahertz patch antenna, and this is another patch antenna for additional frequencies, and this will be pointing at Earth. And this is our standard antennas that we have been using for the VU transponder. So one of our partners, we're getting ready now to do vibration testing on these solar panels. One of our partners a few years ago found out when they were doing vibration testing that after launch, with that vibration from the launch, they wouldn't have been able to open the solar panels. So we want to do some serious testing on this stuff. And here's the electronics and software that we've been working on for years. This is, I shall say, a typical ham shack, perhaps. This is the part of my ham shack where I do software development. Over here is what we call the flat sat. This is the transverse stack with various wires going over to the, let's see, this is the ADCS computer board here. This is the GPS computer board here. These are some development boards. And this is a very early test board of the what we call the CIU, the Central Interface Unit. And you can see I've got a power supply and oscilloscope, actually two power supplies. So this is my fun and messy workspace. So what is the current Golf Tee state? Where are we now? We've done a preliminary design review, so we have a general idea that we're on the right track of things. We had a bunch of people get together and make presentations on each part of the satellite. We do have a meeting every Wednesday night Eastern Daylight Time here in the U.S. And talk about issues that we're having, status of each thing. But this PDR, the preliminary design review, we had a much more comprehensive discussion of each thing that we're doing. So this is a group of stuff that's done or close to done. The legacy computer, the original computer, and this is nearly the same computer that was launched in 2015 on FoxPlus-A, really, A085. The command receiver, the transponder, they've all been used in Fox's and other partner satellites, and they're pretty much done. The EDIS microwave transmitter and receiver has had its RF flows, and this thing runs on. One of these days, I'll remember the name of the software that this thing uses. But in any case, it uses flows to determine what thing the EDIS will do, and those flows are nearly done. There recently, some other software folks have recently finished the software allowing the EDIS to talk to the onboard computers. And similarly, as I've said before, I think I talked about this last year, the basic software is very similar from satellite to satellite. So that's nearly done. We had to add software to allow the extra computers to talk to each other and to fall back from one another, but that was done quite some time ago. We are making good progress on the space frame, on the solar panels. We have a new rad-tolerant onboard computer, and the software for that is essentially all written, although there is a new RTIHU version in work. We've had a version of the RTIHU for years, long enough to develop the software and find out what additional hardware tweaks are required. So those tweaks are designed, and review, build, and test remain. So there's a little bit more building to do in the rad-tolerant onboard computer. And we also have a GNSS system. In the US, we call it GPS. In Europe, I think it would be called Galileo. Russia has their version, China has their version, but generically called GNSS, positioning system. And we have one that is able to run in orbit. So we are building a GPS simulator to allow us to test it on the ground. And another thing that we want to do with this GNSS system is to get our exact orbital, orbital information each time we get some data from that and turn it into TLEs, or more like orbital elements. because the attitude control system needs orbital elements in order to know where it is and what direction it has to point. So we are progressing, but we have a lot left to do on some parts. The power supply, the MPPT, and distribution, MPPT being the maximum power point tracker. So it's trying to get the maximum power out of every solar cell, no matter which way the solar cell is pointed. That is partly delayed due to real life engineer issues, layoffs, moving house, floods, you name it, and partly due to having few backup engineers. Luckily, the engineer working on the power supply is a lot younger than I am, so hopefully he will have less health problems than some of us do. There are lots of software layers to add, including integration between the GNSS and the ADCS, but we know what to do there. The telemetry and commands also are needed for the power supply, but again, we know how to do that. In fact, I've recently done a lot of work using AI to make it easier to put new telemetry in. We have a lot longer delays for a few things. We need to order an ADCS from CubeSpace. We've gotten a temporary, only the computer right now. The lead time is several months, but we can't order it till we have fairly detailed mass properties. The EDIS output is only a couple of gigahertz, so we need to get to get 10 gigahertz, we need an upshifter and a power amp. That circuit is designed, but the builders are overloaded. Surprise, surprise. The latest CIU has been delayed again because of detailed design of everything, and also medical issues. Sounds familiar, right? So of course, then we need to build an engineering model test to find out what else we missed, fix and supply and test the flight model. So we're currently expecting completion or completion ready to launch, but who knows when the launch will actually be at the end of next year, end of 2027. So that's Golf T. Fox 1 satellites, the early satellites that we did were really popular, and it would be awfully nice to launch a lot more. I mean, Golf T is going to still be a couple of years away, right? So we'd like to have more Fox 1-like satellites that we can do reasonably quickly with slight upgrades, but a lot more. But unfortunately, a lot of the original components in the Fox 1 satellites are obsolete, and as we say, unobtainium. In addition, our mechanical engineer from Fox 1 is silent key, so we have to restart some of the mechanical work. So Fox Plus, the point is both trying to recreate Fox 1 with new ideas and components, as well as using perhaps a subset of already completed golf boards and some significant pieces of purchased stuff. So Fox Plus is a program that builds on Fox 1, hopefully with improvements. Click. There we go. So as I say, we want to build on Fox 1 on LTM, which is that group of boards that I pointed out in golf, and other golf stuff that we may be doing. Open source and access. All documents for Fox Plus are on GitHub or on a GitLab. There are a few NDA documents from purchased stuff that we are not allowed to. We're under non-disclosure. The reason we want to do that is that more grants are available for open source stuff, and we want to avoid ITAR issues. And just to clarify, ITAR is a U.S. international traffic in arms regulations. Some parts of satellites, believe it or not, are considered armaments by ITAR. So in Fox and Golf, we've been careful only to have, quote, U.S. persons let's say citizens, working on them as required by ITAR, making everything open source takes advantage of a cutout in ITAR, so we're not covered by it. In addition, some grant sources require open source development. That allows us to apply for those grants for launching and so on. Notice that we still have to pay attention to what's called EAR, again, a United States Export Administration regulation. So if we actually export hardware, that's going to be an issue. Surprisingly, given the weird regulations around our government now, low Earth orbit is not considered an export. Ha! Who knows? Who knew? Later Fox Plus satellites might have additional capabilities. Come on, click. There we go. So here's the flat-sat version of it. Again, this is in my shack. On the left is the the bottom is the Fox Box, is the flash. I'm going to say that again. FoxPlus-A board stack. Actually, this is in the project leader's location. He's got test equipment, as you can see, and on the top is the purchased antenna system from ISIS Space, a Dutch company. You can see also the battery pack to the left, right here, and a board that they call the what do they call it? The PCB, strangely enough, an ISIS test board. On the right is a close-up of the ISIS antenna right here, and it's really a very nice device. It's a dipole. There's antennas that stick out from each one of these. You can see them rolled up in here, and they stick out from each corner. So this is a very nice device, although also very expensive. And this is a pretty good idea of what it will look like when it's launched. On the left, we also bought the space frame from ISIS Space, and you can see it sitting in a construction jig. So this is more or less what Fox-1A. In fact, it's also what Fox-1B will look like. And over on the right there, you see it without the solar panels on the outside. So you can get an idea of just the space frame with the boards inside it. So what's the FoxPlus-A status? We're hoping to get the engineering model stage in a few months, and we'll be purchasing a launch for FoxPlus-A. So exactly when it launches depends not only on the completion date, but also on the launch lead time. So we have a number of new volunteers, which is very nice. We have a number of new volunteers working on it, a great mechanical engineer, a system engineer has they've all been recruited. And because the software is quite similar to previous ones, I'm working on the software. As of now, people are in FoxPlus-A are meeting concurrently with the golf team on Wednesday nights. Cross-fertilization, onboarding new volunteers is always nice. We have also passed a PSR preliminary status review on FoxPlus-A, and the purchased hardware is being integrated into the flat sets. There's lots of time, surprisingly, being spent on all things, on how to integrate the RBF remove before flight pin with the purchased power supply. Now, doesn't that seem strange? The purchased power supply has an insert before flight, and this is just not what we're accustomed to. It doesn't seem reasonable to us, so we are kind of inverting that and trying to get a remove before flight pin on it. And it's also in a different location from what we're accustomed to. It's on the top, that is the plus-Z side, rather than the plus-Y or plus-X side like all of our previous satellites have been. So the software is essentially done as of a few days ago. Bug swatting obviously remains. And so we expect to be ready to build and test the engineering model in Q4 of this year, and then going into all of our flight model testing, flight model building, flight model testing, and so on. So we certainly hope that FoxPlus-A will be ready and in orbit way before Golf T. And that is the whole goal, the whole reason for doing Fox Plus in the first place. So as I said, there are later Fox Pluses. The third satellite that's in progress right now is FoxPlus-B. PACSAT was originally an ASCENT project, and ASCENT is kind of our skunk works. It's where we build things that have no particular launch plans. And there are now a number of things that have come out of that, including the radiation-tolerant IHU that I talked about in golf, that have migrated into real satellites. So PACSAT was originally an ASCENT project that will fly first on FoxPlus-B. Corey Minyard, AE5KM, is the project leader, and I got the slides from him, so thanks to Corey. Many different people are working on PACSAT, although the software is initially based on the standard AMSAT Fox Golf software, but it has a lot of changes. It's using only the RTIHU, and of course, instead of the software to support the transponder, it is supporting the packet satellite stuff. So what is PACSAT? It's completely open source again. It's got a single Pumpkin Space CSKB compatible board. It's FSK and PSK capable packet radio. There's 4 receivers and 1 transmitter in it. It has message store and forward capabilities, storage for experiment data, and it's got high-speed data capable, although FoxPlus-B may not use that high speed. Fault tolerance capability because of the high RTIHU, and it is designed for flexibility. So why are we doing PACSAT in general? Besides messages, it works with files that can be downloaded in small pieces. It's delay tolerant, intelligent small box transfer, and these high speed, both the high speeds and the fact that we can request just small blocks at a time to make up holes in large transfers. That means experiment partners can download more data more quickly. And store and forward allows amateur users to upload messages for later downloads. So it has this traditional store and forward capability, as well as a digital digipeater, which all seems to have been very popular in past satellites. So it's a 1U. It uses the same ISOSpace components as FoxPlus-A. So the picture I showed you before is what it will look like. The ISOSpace components are the power supply and batteries, the antennas, and the space frame. And there's a new board, there's a specific PACSAT board that's designed to fit the existing components. And here's what it currently looks like, the prototype board. The basic software is operating. The ground software is being developed, partly based on FalconSat ground software, and they're experimenting with different speeds. So in summary, golf is making progress after many years, but still probably more than 18 months away. FoxPlus-A, we're trying to fast track that and should be ready in a few months. Whether it launches then is a different question. FoxPlus-B will be a different digital satellite, somewhat like FalconSat, which people loved. We don't have a specific timeline for that yet. And towards the end of my talks, I always like to put in launches because that's my favorite thing. So this is AO91 being launched. Excuse me. And so I want to thank you for listening. Thank you for asking me. You can see that we're making progress. As you well know, space is hard. It's even harder when we work with donated funds and volunteers and a somewhat aging labor force. So thanks for listening. Thanks again for inviting me to speak at the AMSAT South Africa Symposium.